All right, today we're going to talk about linear equations, standard form, slope-intercept, point-slope formula, and the slope formula. So really, can we identify which one to use and be able to graph that equation? Okay, so up here at the top, linear equations. The first thing we're going to talk about is what a standard form look like. So normally standard form is written as ax plus by is equal to c. Okay, so in standard form, the x and y variable are on the same side of the equation. Okay, and then from there we talk about slope-intercept form. This is the most common way you guys are used to seeing your equation written. It's y equals mx plus b, where m is the slope and b is the y-intercept. Okay, it's the most common way that you're used to seeing that. And then we have one other form, point-slope form. So point-slope form says we have y minus y1, which is equal to m times the quantity of x minus x1. Again, m is just the slope. This time I'm going to write it up here. So m still stands for the slope. And then we also have a point, and that's why we label it x1, y1. So it's just the values of a point. Okay. And then, of course, the slope formula. So how do I find slope? I'm going to have y2 minus y1 divided by x2 minus x1. So basically, you need 2 points to find that slope if it's not written as slope-intercept form or point-slope form. All right, so let's kind of talk about this. All right, we have 4 examples down here. And this one is slope-intercept. So number 55 is slope-intercept form. So that tells me that this is the slope and this is the y-intercept. Okay, so we can simply say m is equal to negative 4 over 3. B is equal to 2. Okay, another way to write the y-intercept would be 0, 2. And so when we're graphing this, right, if we're doing this by hand, we can put a point at 2. And then from that point, we use our slope. So we have negative 4 over 3. So negative tells us to go down. So we count 4 down, 1, 2, 3, 4. And then 3 to the right, 1, 2, 3. And that leads us to our next point. And then we can simply connect those 2 dots. And there's my graph. Okay. Number 56 is in standard form. Standard form because the x and the y are on the same side. So if I wanted to graph this, then I probably need it in slope-intercept form. So that means solving. So we'll start solving for y. So we have to subtract x to both sides. That leaves us with negative 2y on the left, negative x plus 6 on the right side. And then I have to divide everything by negative 2. And that leaves me with y is equal to positive 1/2 x minus 3. Again, here's my slope and my y-intercept, my m and my b. So I start with my y-intercept, negative 3. And then this time my slope is positive, so I'll go up 1 and right 2. And I can continue that pattern if I need to. And then I simply connect those dots. And there's my graph. Okay, so 51 and 58 are a little bit different. Notice that both of them only have one variable. So how do I show that? So this is number 51 says y is equal to -4. Okay, so y is equal to -4. 1, 2, 3, 4. So that's technically my y-intercept. Okay, and basically it's saying y is always equal to -4. So I'm going to show you a series of points where y is always equal to -4. So if I wanted to connect all those dots, that just forms a horizontal line. Okay, so this is technically the y-intercept, right? Then number 58 has x equals 1. Okay, well technically this is the x-intercept. So here is when x is equal to 1. Again, that says x is always equal to 1. So this series of points is where x is always equal to 1. So we have a vertical line. Okay, so let's move on to the next sheet. We're going to skip down to the linear equations again. Oops, it's back up. Here we go. All right, so here's where I have to use the formulas I had just a while ago. So in problems 59 through 62, they give me 2 points. Okay, and it wants us to find the slope of the line passing through the given points. So I just want to find the slope, and that is it. So I'm going to use the slope formula that we wrote down, which is y2 minus y1 divided by x2 minus x1. So I'm just going to rewrite that up here. So to find the slope, we take y2 minus y1 divided by x2 minus x1. Okay, so what does that mean? Right, well, I'm going to label each point. x1, x2, y1, y2, right? And so to find my slope, I have to fill in this information, right? And so it doesn't matter which point you label. That subscript just says, hey, this is the x value of my first point, or this is the x value of my second point. And again, the order doesn't matter in how you label it. It just matters when we put it in the equation. So we always get y2 minus y1. So I'm going to erase y2, and I'm going to put a 6. Okay, and then y1 is -9. So I can do one of two things. I can say 6 minus a -9, okay, or minus a -9 is just simply 6 plus 9, right? So 6 minus a -9 is the same thing as 6 plus 9. And so then I do the exact same thing with x1 and x2. So I take x2, which is, let's do that in purple. x2 is 2 minus -4. So minus a -4 really becomes +4. Okay, and then now I just work this problem out. So we have 9 plus 6 is 15 divided by 2 plus 4, which is 6. And then I believe that gives me 5/2. So that's as simplified as it gets. Or if you like decimals, then we can do what, 2.5. So that's how you find the slope. All right. So again, number 60, we label. Again, it doesn't really matter. Watch, I'll label this one x1, y1, x2, y2. And then once you label, we just use our formula. So we had y2 is 6 minus y1. So it's minus -1, right, which becomes a positive. And then we have x2 is -10 minus a -3, which is a +3. Okay, so I can just change that. And so now I have 6 plus 1 up top, 7. Negative 10 minus 3 is a negative 7. 7 divided by negative 7 gives me a negative 1 as a slope. And then 61, x1, y1, x2, y2. So I have negative 2 minus a negative 2. Those two minuses together gives me a plus. And then I have a negative 1 minus 3. So I get 0 over negative 4, which is just 0. So we have a slope of 0. A slope of 0 is simply a horizontal line. Okay, so my line's going to be level. It's going to look like that when I graph it, when I connect those two points. Okay, and then the last one, x1, y2, or sorry, x1, y1, x2, y2. So again, the slope, y2 minus y1 over x2 minus x1. So this becomes a plus. That's 12 over 0. Anytime we divide by 0, it is undefined. So we have an undefined slope. What does an undefined slope mean? That we're going to have a vertical line. So when I were to connect those 2 points, I would have a vertical line, which is considered an undefined slope. All right, so now that we've practiced slope, we can move on. And we are going to write an equation now, okay? So this is probably what is going to be the most difficult. So we always figure out what we're given. So here we're given a point. So this is a point, right? We can just label that x1, y1, x1, y1. And then we're given the slope. Okay, so we're given a point and a slope. And so when I come back to my my formulas, I notice that I have slope-intercept, no, standard slope formula or point slope formula. So I'm given a point and the slope, so we're going to use the point slope formula. So that formula is y minus y1 is equal to the slope times the quantity of x minus x1. Okay, and really all I have to do is fill in. So what I'm going to do is fill in the easy one. Slope is 1/4. So I erase the m and I put the 1/4, the actual value. Then I substitute in for x1. x1 is negative 6, right? So we have, again, a minus negative 6. So minus a negative becomes a positive. And then y1 is 1. So I just have y minus 1. And so that is point slope form. And now what they want us to do is write it in slope intercept form. So in order to do that, I have to simplify and solve this equation. So the first thing I do is distribute. So I have y minus 1 is equal to 1/4 times x is 1/4 x. 1/4 times 6 gives me 1.5. So I can just keep it as or I can just use a decimal. It's probably the easiest thing, right? And then from here, I have to solve for y. So I have to add 1 to both sides. And so I get a final answer of y is equal to 1/4 x plus 2.5. So this is my, this is my slope intercept form. Okay, that's given a point and a slope. Now in 64, we're given 2 points. Okay, so 2 points. So the first thing I need to do is find the slope. So I label my points. And then I use the slope formula, negative 7 minus 13 over 2 minus a -2, so minus a negative becomes a positive. So that gives me -20 over 4. -20 divided by 4 is -5. So the slope is -5. So now I know the slope and I know a point. Okay, I'm just going to pick a point that I think is easier. So I have a point and I have the slope. Okay, so again, I'm going to use point slope formula. So I have y minus y1 is equal to the slope times the quantity of x minus x1. And then I just substitute what I know. The slope was -5, so I substitute that in. x1 is, I'm using that point that I circled. It doesn't really matter which point you use. Is 2, and that's why I'm using this one. I think those numbers are easier. And then this one is a -7, so a minus a negative becomes a positive. And so now I need to solve by distributing. Y plus 7 is equal to -5x plus 10, because -5 times -2 is plus 10. Then I need to solve for y, so I subtract 7 to both sides. And then what I'm left with, so I'm going to write it up here. Y is equal to -5x plus 3. Okay. And then the last one just says, give an example of a line that is parallel and a line that is perpendicular to this problem right here. So anytime we're talking about parallel or perpendicular, we're thinking of the slope. So I need to figure out, what is my slope, right? Well, I'm given an equation, and to find my slope, I simply need to solve that equation for y. So when I'm solving, subtract x to both sides. 3y is equal to -x plus 10. And then I have to divide 3 to both sides. So what do I get? I get y is equal to -1/3 x plus, what, just 10 over 3. I'm just going to leave it as a fraction because it'll give me a repeating decimal. And really the only important part that I want is the slope. So the slope is 1/3 or -1/3. Okay, so let's talk about this. That's my original equation. The slope is -1/3. And so if something is parallel, then that means they have the same slope. So I can create an equation, y equals, I use the exact same slope, 1/3 x, and then I can just pick whatever y-intercept I want. Like I could pick 17. Okay, but it has to have, again, the same slope if you want it to be parallel. So then if we're talking about perpendicular, okay, perpendicular means the opposite reciprocal. Okay, opposite reciprocal. So opposite reciprocal is the opposite of negative is positive, and then the reciprocal of 1/3 is just 3. So I have a slope of 3. So I have y equals 3x, and then again, I can just pick whatever y-intercept I want, so I could pick like -1. Okay, so this slope is the opposite reciprocal of my original slope over here, -1/3.